So smiley face. Thanks, Greg. Can everyone hear me okay? Perfect. Thanks, people. And welcome to the introductory session of the Advanced Diploma of Industrial Automation, the DIA 20 program. I'll leave this first, thanks, Dick. I'll leave this first screen on for you because in the yellow you'll see that it shows you how to configure your audio. It's super important that you do that when you log into a webinar. It means that you'll be able to hear the instructor much more clearly, and the instructor will be able to hear you also really clearly. So this is the Blackboard Collaborate. This is the webinar room that we'll be using for all of your webinars. There's just the one room link. The thing about this room is that this room is used only for your course, the DIA 20 course. What that basically means is that you can use this room anytime you wish. So you'll be spending a lot of time in webinars with other students in the course. So it's really a great opportunity if you want to catch up and meet up and discuss anything really. It doesn't have to be about the course. It could be like if you've got new technology at your work, or if you're doing something interesting and you want to share that with different people around the world. This is your room. So you'll be able to meet up with a whole range of different people in the course. There's about 35 students in the course. So yeah, hopefully you'll make some good friends throughout the course. We've been through the configuring of the audio. Hopefully you're all able to do that fairly easily. Now we have obviously the microphone that I'm using at the moment. You'll be able to talk in the webinars. The key to the microphone is you click the talk button when you want to speak. But when you finish speaking, please don't forget to click the talk button again. That means that other people will be able to use it. Now we have the direct messaging. Most people are nowadays pretty familiar with the direct messaging. We use it a lot on our phones and things like that. And you've also got the opportunity to use the different emoticons. So for example, if I'm an instructor and I'm speaking too quickly, for example, using an emoticon, what can you do to make me slow down a little bit? Just using an emoticon. Any ideas? Perfect, Greg. Slow down, please. There's a range of different tools there, and the instructors are very, very familiar. And they monitor the chat boxes. They monitor what you're doing to make sure that you're following along with them. They'll ask you questions also throughout the webinars, so it's really important that you communicate. Now we have the different whiteboard tools. Can anyone feel like scribbling on the whiteboard? Maybe write hello on the whiteboard, or anything at all. Just make a big mess of the whiteboard. Perfect. Perfect. So you've got the ability. If there's a word you don't understand, you can point to the word. There's a range of different tools. You can draw all over the whiteboard. Perfect. Anyone else want to? Why? Yeah, that's right. Well, there'll be times when you want to maybe communicate with the instructor. Maybe there's a word you don't understand and you want to underline the word, and things like that. So there's just different tools. There's different ways that you can communicate with the instructor in real time. Now, also, every session is recorded. This session is also recorded. When I come into the office the day after the webinar's been conducted, I'll upload the recordings to Moodle automatically. Everything will be on Moodle for you, so it's just a matter of having a look at the recordings. I find a lot of students like to look at the recordings, even if they attend the live webinars. Maybe there's something they miss, or maybe something they want to get just listen to again. The recordings are all there for you if you want to view them. Now, can anyone tell me what is the attendance requirement in order to graduate? Does anyone know? What percentage of the webinars? 70%, exactly. Perfect. Now, if, for example, we understand you're very busy people, you have, busy professional lives, family lives, social lives. If you're unable to attend a live webinar, what can you do to make up for your attendance? Any ideas? So if you're not able to attend a live webinar, there's something you can do. That's right. Perfect, Greg. Yeah. So you can submit you can email, you can complete a webinar summary and email the summary directly to me. The template to use for the summary is on Moodle. So watch the recording, complete a summary of the recording in your own words. And once you've done that, then you can email that summary to me and I'll mark you as having attended the session. That will go towards the 70% attendance requirement. All right, just today we're just going to talk a bit about the course. So I'll just do a few administrative things. I won't keep you for too long, and then I'll hand you over to Dick Morley. So my name is Paul Salenza. I'm based in the Western Australian office. Can anyone tell me what time it is here in Perth, in Western Australia? Any ideas? That's right, about midnight. So normally I wouldn't be online at the moment, so I'd usually be asleep in bed. So if you email me at this time, I won't receive the email till the next day. And the first thing I do when I go into the office every day is the recordings. Get the recordings up so you've got the opportunity to watch the recordings, and then I'll start tackling the email. So just be a little bit patient with the time zones. I will respond to your emails as soon as I can. Now, in order so I can respond to your emails very quickly, please don't forget to put your course code on the emails that you send me. Can anyone tell me what the course code is? What's the course code? It's Advanced Diploma of Industrial Automation, but we make it short for communication purposes. I see everyone's typing. DIA20, that's right. So if you can, in the subject line of the email, just type in DIA20, and then I will understand which course you're in very, very quickly, and I'll know how to help you. So we use Moodle. Everyone's familiar with Moodle. You must be familiar with Moodle if you've been able to log into this. What is Moodle? Can anyone tell me what Moodle is? Any ideas what Moodle is? No? Moodle is a learning management system. You can all understand that if I was to email you every recording, every slide, every reading, every assignment, your emails would get very cluttered very, very quickly. So Moodle is basically a website. It's a learning management system, and it's our major communication tool for the program. It allows us to put everything you need for the course into one place. You'll be able to access that 24 hours a day, 7 days a week. Everything to do with the course should be on Moodle, and if it's not, then let me know, and I'll upload it for you. But that's the place to go to find everything you do need. So hopefully everything's on there for you at the moment. All of the documents that you need, and also all of the information for Module 1. So it's all there. Hopefully it's user friendly. Hopefully it's set out in a way that you can easily find what you need. Everything will be basically contained within each module. You've got the welcome section. Obviously you've got all the webinar information, all of your schedules. They're all in the one place. It makes it easy for you to find and to know what's coming up. We've also put a few other things into Moodle for you. Some computer basics, maths basics. They're not really part of the DIA20 program, but we find that a little bit of extra computer help. Maybe some people don't know how to do a screenshot, or not sure. They're very, 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 very basic computer skills. Some maths basics. If you're looking at buying a home loan, I recommend the maths basics. We have a different instructor for every module, as you would have seen when you were looking through the brochure of the program. The modules are very, very different in nature. So we've got a specialist in each area. for each module to help you through that particular section. And all the instructors have very different skill sets, and they will help you. Please remember that you can communicate with the instructor. Obviously, you can communicate with the instructor in the webinars, but you can also email the instructor. Maybe there's a question in the assignment that you're not sure how to answer. Please make use of the instructors. They receive emails all the time from the students, and they're happy to help. If you're not sure of the instructor's email address, just email me, and I'll forward that on to the instructor to help you out. Every module will have an assignment and a quiz. With the quiz, you'll need to get 100% in every quiz, but you'll have 3 attempts at those quizzes. The quizzes will be due at the midpoint of the module, and the assignment will be due after the module has been completed. The assignment will be split up into 2 sections, the theory part of the assignment and also the practical assignment. Does anyone know how do we do practicals at EIT? What would a practical be, for example? I see Greg's typing. Remote labs, fantastic. Has everyone, can I have a smiley face or a yes in the chat box? Has everyone had a chance to log into the remote labs yet? Yep, fantastic. Fantastic, really great. Fantastic. So while we're here or online, can anyone tell me the password? What's the password for the remote labs? Demo pass. Please remember that, demo pass. Exactly. Demo pass, that's the generic instructions. So you've got the generic instructions that you've used, and you'll also have instructions on each practical assignment for the specific lab that you need to go to. So it should be very easy for you. The logging in part's easy. The challenging part will be actually completing the task. So hopefully you'll learn a lot and it'll add a little bit of value to your understanding of things. I won't keep you too much longer. Just the due dates will be on the assignments themselves. I want to make a special note of plagiarism. Please note that the assignments need to be your own work. Please don't copy and paste from text. Please answer all of the assignments in your own words. Essentially the reason is because the students need to demonstrate that they understand the questions, because it's a formal qualification that we're delivering, and we need to make sure that all the students understand obviously all the learning outcomes and the assessment criteria. So we do monitor plagiarism. I'm not saying anyone here will do any plagiarism, but we do monitor it in a couple of different ways. We have that Turnitin software, the plagiarism software, and obviously the instructors. They're very attuned to plagiarism. Penalties will apply. If you're falling behind, if you feel that you get a work project comes up, if something happens and you're not able to meet a due date for an assignment, that's fine. We understand that. Please contact me before the due date, and I'll assist you with an extension. The other piece of advice I would give for the course, it is a very intensive course, so please allocate time every week to the course. You'll find that if you don't do any study for a 2 or 3 week period, it starts to build up, and then the stress builds up as well. So my recommendation, after having done this course many times, please allocate every week, set amount of time every week to going through all the readings and the slides. If you do that, you'll do really well in the course, and I think you'll make the most of it and you'll enjoy it. Obviously, there will be some challenges. For those, there was a challenge actually with the introductory session earlier today. If there's any challenges, any problems at all, just email me, let me know, and I will we'll work through these challenges together. Obviously, whenever you're using software, as you would know just as well as I do, that things can go wrong. Computers, they sometimes don't do what you want them to do. Please just communicate with me if there's any problems at all, and we'll work through them, and I will assist you. The Module 1, Instrumentation for Automation and Process Control. We have a very experienced instructor there. His name is John Pipperides. He's got a lot of experience, very skilled too as an instructor. So he'll help you with the module module 1. All of the information you need for module 1 is already on Moodle for you. If you're not able to find the schedules, if you're not able to find I don't know, the readings or anything like that, just let me know and I'll direct you to it. Thank you everyone, and welcome to the Advanced Diploma of Industrial Automation. I really hope you enjoy this course. I think it's a fantastic course. We've run this course many times, and I think it is the people that graduate are always very, 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 very happy they've completed the course. It's a really good course. I look forward to communicating with all of you throughout the course, and I sincerely wish you all well in the course. What I'll do now, the slides are empty. Are the slides empty? Funny. All right. It's not been a lucky day for me at all today. I will pass you over to Dick Morley. Over to you, Dick.
Dick Morley, how you doing? There we go. Can I have some in the king? You hearing me? Can you hear me? Yes, good show, good show. Now let's move along here quick, one way. I'm going to give you a little bit of history, a little bit of the future, because we have to do both. We don't have our slides here. Here we go. This is me, Programmable Controller. Well, as you may have read, I am the father of the Programmable Controller. The reason I say I'm the father is because there were about 20 of us who started it, and nobody really invented it per se. I guess I was part of the keystone, but I refuse to call it the inventor. Programmable Controller was done to solve a problem for me. I was working in Bedford Associates. One moment, please. It was New Year's Day in 1968, the Programmable Controller. And everybody says you invent things based on other people. Not true. You invent things because you're annoyed at the world. It was New Year's Day, and I had a terrible hangover from New Year's Eve. And I did not want to write another proposal on another automation application. And I was late again. I know most of you fellows are women. I'm never late for proposals, but I'm always late. But I did notice there was a similarity across all the applications I have been doing. And I'm lazy, which is a good thing, I guess. And I said to myself, what I need is something that tolerates heat. In other words, it's bulletproof. It's aimed at electricians, not academic, not software people, not physicists. My background is physics. And it's got to be never off. It's got to be like a toaster. The toaster business, the toaster is never really off. It's just when you command it to do something, it'll burn bread. No problem. So I over-engineered it. They somehow thought that was a problem, but I didn't think so. It had to be Coca-Cola proof. You know, one of the most popular used words in all languages is Coca-Cola. Wow. And I wanted to make money while I sleep. I don't want to make money by having to work for it. We're all the same way, of course. An impossible dream, you say? Well, I don't know if it's an impossible dream. One moment, please. The hardware had no off switch. There was less than apparently all running. There's no off and on switch. Even today, many of their programmable controllers have no on-off switch. It's always on. If there's power there, it's running. It has to look good to the factory floor. It has to look good to the food processing plant. It has to look good to building controls. If it looks good, I mean, it's got to fit in there. It looks like a piece of gear that belongs in the environment. It had to be power voltage insensitive. We ran it from 75 volts to 250 volts AC, 50, 60 hertz. You could use it anywhere in the world and plug it in. It had to be rugged. It had to be able to be dropped on the floor, Coca-Cola poured on it. And cost is a bad word. Let me tell you why cost is a bad word. Cost is a word that's overused. You look at the cost of a control unit, and you try to get the lowest possible, cheapest possible controller. That's not a good thing to do. If the controller is down for 5 minutes, and you miss making one automation, automatically missing making one truck, that's a big cost. You want it not to fail. You want the cost of the product being made to be minimized, not the cost of the hammer you use to make the things. Remember, the cost of the tool is not the when a good carpenter software guy has very good tools, and the hardware of a programmable controller is a tool for automation. We need to do it for automation. Low cost is a problem. Not low cost of components is a problem. Not the low cost of automation. Like when the automation system goes down, I remember General Motors saying, I don't care what it costs, get it up and get it running. We're missing a truck every 5 minutes. That's cost. Cost of product, cost of use, cost of environment, not low cost of equipment. See, as engineers, we think of it when you're a carpenter, you want the cheapest possible hammer, the cheapest possible screwdriver, and a manual saw. Not so, my good friends. Cost is a 4-letter word. Remember that. Come on, you. So the next one is unloadable, apparently. The software is the next one. Software is something that you don't want to mess with. You don't want to have to learn some new academic software. You want to learn software much like your cell phone. Your cell phone is not a piece of software. It's magic. You want magic to happen. And you don't want to have to go through the mechanizations of software compatibility and the rest. You just want to have it make it done. So we built the software to be like a music box. Wind it up and turn it, and it goes ding dong, ding dong. The little pins hit, and the little pins are your software programs. Our markets were different. Interesting. Anyway, the markets were different. The markets were automation and building controls. And we wanted to make sure that the guy who was running the programmable controllers is a person who is used to dealing with the problem, not dealing with the software academics. I was in a shop, machine shop, my dad tells me, when I was 14 years old. At that time making $150 a week, which was amazing money for a 14-year-old person at that time. But anyway, since I was in the factory all the time, I knew the mindset of these intelligent mechanics who did not want to learn a new technology to make a slave run. And it had to be mechanical projective. The programmable controller had to be mechanically compatible with the system. It had to be rugged. It had to use, as we mentioned earlier, the power had to be done correctly. And we had to solve real problems. We had to be able to deal with the future. As engineers, we're obligated to deal with the past and know what the past is. But since we have to deal with programmable controllers and automation systems and robots for the next 20 years without interference, we have to know what the future will be. The future is a situation that many of us ignore. But if you don't know what the future for the next 5 years, up to the next 20 years is, you're in trouble. So you have to be a little bit careful. Don't believe the hokum, but believe what's reasonable. In other words, in 5 years, we're going to have to deal with voice control. We're going to have to deal with applications. We're going to have to deal with things like the iPad and iPod. We're going to have to deal with the modern telephone use. All of these things we have to deal with in these problems associated with controller systems. So the future and the history. 60 years ago we didn't have, for example, I don't understand why I'm not loading you. Hold the phone and make sure I get this loaded. Hang on a minute, I'm still here. No go, I guess in my computer it's off or something. Let me get back to my list here. The future is history. I like to talk about the moving now. I'm a fan of physics because my background and training is physics. But physics is in time. The only time you have is now. If you design for now, you're suddenly obsolete within 1 second. You have to design for the next 5 years, not 20, but at least 5 years. You have to be able to do that. You have to deal with it as it happens. For example, 60 years ago, we didn't have microwave ovens. We didn't have jet engines. We didn't have computers, tabletop computers. We didn't have so many things. And nobody believed that we would have, for example, Siri, the telephone that talks to you. The telephone talks to you. That's magic. I ask a question of somebody who whips out his telephone and has the Library of Congress at his beck and call. That's amazing. That's magic. In predicting the future, you're always not predicting the future with too much conservative things. For example, we decided to pick the future And we did a lot of things. We were about 60% right on the predicting the future. For example, we felt that radar ranges would be here because of, and this I know because I talked to his grandson, the fellow who had chocolate melt when it was in his pocket and he walked in front of an airplane that was running radar. We also said that there'd be continuing wars, more and bloody and much more. It looked like wars of guerrilla warfare, not regular warfare, and that happened pretty well. We thought there would be supersonic aircraft, and we don't have that, not yet, and maybe never, I don't know, but it's not yet. But we feared it was going to happen, so we were mistaken there. So we want to predict the future. We were right about 60% of the time in our predictions. Now, in terms of manufacturing and systems, the miscellaneous techniques needed and wanted. We want to be totally wireless everywhere. Now, gentlemen and ladies, don't get upset. I mean everywhere. The guys used to say, isn't wireless, and my office isn't wireless unreliable. I said, you don't have a cleaning staff that comes in and pulls out the plugs, sweeps the floor, and puts the plugs back in the wrong socket. That's real reliability, not software reliability. So what you want is wireless, and I took all my cables and put them in a big bag and reminded me on my desk all the amount of wires and trouble I took out. Wireless facilities don't go down, but I do if I do the hardware. The mechanical side. I thank you, Mac, for it. I'm having trouble getting my slides up. Thank you for joining my session. Mechanical side. We have to know as engineers everything about a mechanic stuff. We have to know gears, we have to know motors, we have to know strength of materials. We have to be a sloppy physicist, if you will. We have to know about all the physics of electricity, electronics, software, mechanics, the fact that a straight line or a straight surface has no strength. For example, I always wonder why we always make things straight with right angles and straight lines. There are no right angles and straight lines in the nature. Nature has all curved things and tempered things and tapered things. They're all built like the Eiffel Tower. We need to understand that both our software and hardware have to look like an Eiffel Tower of one source. Energy comes in many forms. The one we like is the energy. That's the slide with energy. The energy is many forms. Right now, it's mostly the physical hydrocarbon stuff. We dig it out of the ground, use oil, and that's a major portion of our energy. There's a small portion which is solar, which can deal with maybe 10% of the world's needs instantaneously, not stored. So we have a problem. What do we do about energy? Well, one of the things is atomic power. You can have atomic power by having heavy atoms and molecules and breaking them. And the breaking of them, you leave iron as an ash, and neutron heat runs turbines. Or you can take hydrogen. You might take hydrogen out and punch them together and make helium. And that's a very efficient but difficult to manage system. The fusion most of the atomic power is fission. I'm impressed with the Germans getting rid of all atomic power. I don't understand why. I mean, it has no side effect, but it does have a perceived danger factor. Like the danger factor of automobiles is high, the danger factor of oil is high. So you say to yourself, we're doing science as a democracy. not as a real analysis. My dad told me a story one time. He says, Dick, he says, you have to remember, you have to not infer stuff. You have to know what stuff is. He told me, what does it mean when you're driving behind a car, slows down, it goes to the right-hand side of the road, and blinks its right light? What do you know for a fact? Remember, blinking right light, car slowing down, and you're bearing to the right. It means that the bulb in the light is not burnt out. That's the only thing you know for sure. For sure. You can't know something that you infer from stuff. We do a lot of inference, of course, and make connections that are rather difficult to perceive initially. But that doesn't mean that's the fact. The fact is, that bulb blinks. The bulb is not burnt out. That's the only thing you know for sure. And we have to make sure we do the right things and make sure that all of that stuff is not inferences. For example, atomic power is bad. Why? Before we answer that, what about global warming? Well, say global warming goes up 1/10 of a degree. Turn the air conditioner up. Instead of trying to modify the world and the environment, live with it, live with the environment and make it happen and make it so. Same with startup of companies. I've helped start up many companies. And the companies have to deal with the environment that is, not the environment that you wish had. You can't wish for the environment. You have to deal with the environment the way it is today. And that's what you have to deal with. You have to live with when you have a child. And I've raised 40 foster children. You have to deal with the child the way they are, not the way you wish they were. So that's important to everybody as well. Now, the energy is a key element. We have to be able to, have to be able to deal with in the next 20 years. Fusion power, hydroelectric power, solar energy, all that sort of stuff. I always wondered why we don't run our hot water through our septic tank to heat the water up before it gets in the house. Anyway, that's silly, but anyway, we have to deal mostly in our education of what will be, not what used to be. We don't fight wars, but people prepare for wars using the weapons in the last war. As they say in the military, everybody's fighting the last war, and they're never prepared for the next one. And up comes ISIS. So my suggestion is we look to the future for the solutions of the future, not the past. I'm not saying history is bunk, as Ford said, but it deserves only a portion of the discussion. We also have to have, come on, you stupid thing. The best advice I give for people who I work with on the system is that you design a system. Work with very reliable components. As Einstein said, make it as simple as you can, but no simpler. Simpler is good. Nobody I know knows all the assets of your cell phone. Nobody knows all the things you can do with your cell phone. Nobody does. So the new cell phones are just access to Google and the world. And in that sense, you have access to everything. So it's an all or nothing situation. Very noble cause. I love the new phones. They're great. They're really great. The best advice, build systems with reliable, simple components. Components that we know will operate like programmable controllers. Restaurants that are fast food restaurants that only make a certain limited menu. We used to get our hamburgers at the drugstore. And drinks were made, not bought in the drugstore. Even now when we go shopping, the biggest stores in the world are Amazon and Walmart. And Walmart has limited access revenue, minimize inventory, as does Amazon. In fact, I guess Amazon is my biggest buy person. I think it's because I can do it at 2 o'clock in the morning. When I'm trying to arrange this talk, 2 o'clock in the morning, I can look at the system. So you want to build a system? What you want to give to the thing is the management capability of the system. Management meaning that the guy who has making cars knows that he's making a good car or a bad car, knows how much money they cost to make, so he knows what the product cost is, and he wants it never to fail. The General Motors guys used to say, I don't want the automation system to fail. I don't care what it costs, bring it back up fast now. I'll spend that money today ahead of time. And you won't get that call at midnight saying, the system is down, the system is down. You don't want those telephone calls. So we all get them. You really don't want them. The opportunity is there. The opportunity is there to do the kinds of things we need to do. The opportunity of being able to have systems that work, some simulations that work, future projections that work, and not being a denier. I'm doing a call-in lately on a denier system. Everybody denies it. Give an idea that many people denied at one time that you didn't have to sterilize surgical instruments because nobody ever heard of it. It's baloney. You got to hear it. It's baloney that, stem cells, not stem cells, fish pills help your intelligence. That's baloney. It's baloney to say that we don't know the solutions for forgetting stuff to improve brains. It's a baloney that we don't be able to control cancer pretty well now, much better than we used to. Don't deny stuff. Open your heart. Go look at the web. Look at stuff you're building. Look at vendors and make it so. I recommend generally that you build your equipment from one major source so they're compatible with each other. Again, the cost of a single element is not important. The ability to put them together, have them work is. So the opportunity is here for us to make a good buck, satisfy our country, our company, and our living. And that's what we got to do. We got to do all of them. We have to work with the best thing we can do with it. Now, how we do this? Let's get a little bit far out. Our computer. Our computer is a super telescope, a super microscope. We can look at atoms. We can look at the far images of all thing, all with simulation on computers. So computers are the thing we want to do. Computers are the answer to our visualization. And as that gets more and more, someday the visualization will be mentally connected. They already are connected to our eyes and hands and telephone systems. We have all the knowledge of the world in our little telephone. That's magic, absolute magic, and we're going to see more and more magic. If we have electricity, we can grow crops like we grow marijuana on the racks of hydroponics. So as long as we have electricity, we'll have food. As long as we have electricity, we have materials. Three-dimensional printing is coming up fast, much faster than we thought it would. Most of these things do take 20 years to happen. But nobody believed that germs were here. Nobody believed that you could transplant space. Nobody believed that the mosquito was a passenger for malaria. It takes 10 to 20 years to get over the denial. Be careful, but don't be a denier. Accept it for the time. Go and open the refrigerator door and see if the light comes on in your refrigerator. That's the important thing. I do recommend, by the way, that you continue to go to school. I continue to go to school, everybody does. These courses are that sort of thing. You learn about the future, and you may or may not believe it, but luckily that's not my problem. you think differently, and that's important. Go into school and education and technologies with an open mind, not a closed mind. And on that note, we think we can have it for today. And we thank you for listening to us all. And come back to me. My email, by the way, is Morley, M-O-R-L-E-Y, @barn.org. Let me put that on the chat line here for me. You want to get in touch with me? Hold the phone. I'm always good for a physics discussion anyway. Morley, M-O-R-L-E-Y, @barn.org. Or you can use Morley at my fingers are flying over the keyboard here. Hang on, I'll get it. alum.mit.edu. And both of those are good. The best one is Morley at barn.org. Because I look at that source twice a day. The other one I look at less likely. But it's more prestigious. So I'm an MIT guy. I'm a physicist. And as such, I'm a sloppy engineer. But what I want to do is never come back to a problem. I want to do a problem, get done with it, and leave. So if there's any questions right now, I'll answer some questions right now if you got some. Any questions? Type them out for me. Did you like my little talk, by the way? I can't go skiing, no. My legs are bad. I'm 82 years old, and my legs are bad. I run around in a wheelchair now. It's a motorized wheelchair, and there's all goodies on it, but it's still a wheelchair. So I'm stuck with that. I'm 82 years old. Well, thank you for your time. Well, that's good. And but the other thing is, educate some kids yourself. Pick up kids. Get a foster kid. Or hold a course on any subject at all. Hold a course on selection of automation controls, or the best automation systems, or go to a conference. I like a couple of conferences I go to, which I don't have an interest in, is COFES, Congress on the Future of Software, COFES. It's a nice little conference. Tickets are a little big. I think the tickets are about $2,000 bucks. But you get 4 days of heavy counseling on your software. My job when I lecture there is to give everybody a headache. Everybody giving you a headache. And as Einstein said, keep things simple as you can, but no simpler. What's the name of that course? It's a conference, COFES, Congress on the Future of Software, COFES. COFES, COFES. I go to those. I've gone there 12 years, I guess. By now they let me go for free, but I think the ticket is about $2,000, if I'm not mistaken. But it's a wonderful vacation. It's in big golf course down in the area. You can play golf if you want. Food's good. We usually go to an astronomy, take an astronomical look through an astronomical telescope. Let's see, what is it, age 7 to 10? Yeah, but I'm saying my best students are the 30-year-olds that say, is that all there is? I give them a headache, give them a 2-day headache. I recommend you go to MIT or on the East Coast, and it's the West Coast one. Can't think of it. But with the East Coast and West Coast schools, and they put 2-day or 4-day courses, and it's the best vacation you'll ever have. Where you go to people a lot smarter than you, know a lot more than you. Remember, I'm in the bottom of 30% of my class. So you really get a headache. And it's wonderful we have those vacations. MIT and Caltech both offer summer courses, as well as Harvard, that are worth going to. I'm suggesting that you pick one of those three, not the little ones. Go for the big ones so you get the ideas and the icebox opening up. Regular courses are fun, but I'm talking about knowing what you don't know. See how can you know what you don't know? I don't know. Anyway, back at the ranch. So you want to deal with smart people no matter what. No matter what the course is. Knitting is something that's smart. I thought I was in this course alone. I don't know. That's what you want to do too. This course is like that. This course is in between what I'm talking about. The course I'm talking about is take a physics course or a philosophical course, a 2-day course. The course you're in now is about a year, and you're going to learn all about controls and whatnot. That's a down in the dirt course, which is a good course. And we talk about both the future and the past. That's important. But right now, I'm advocating that you take formal courses and wild-ass courses that you only spend 2 days at it. GoFest is one, Caltech does some, MIT does some. They run 2-day courses, full days. So all education is good, and particularly the education you don't know what you're doing. Well, you're learning something here, you'll learn a lot here, but I think this course is about a year long, if I'm not mistaken. But you won't learn about, for example, how you lose thermodynamics. Thermodynamics is very simple once you get it. Thermodynamics has 3 rules. You can't have positive, you can't make nothing into something, you can't have perpetual motion. In other words, you can't get more output than you get energy out than you put in. You actually can't even break even. You can't get out of the game. So knowing those laws of thermodynamics is important. You can't win, and you can't break even, and you must play the game that other people decide for you. And those kinds of things you don't get in a regular course. They drop in a computation right off the bat. By the way, there are 2 kinds of physicists. Physics who can see stuff, that's me. Physics who can use numbers, that's Feynman. I'm sorry, not Feynman. Mario Goldman. Feynman was the only physicist I know that could do both. See what's happening and do the math for it. So they always use me and Mario Goldman as co-authors and co-presenters, both of us. So altogether we maybe make half of a Feynman. Feynman's wonderful reading, wonderful books. Let's see what else you got here. Let's see, any other questions? Yes, and you're in this course and you're going to learn what you don't know. That's true. Hopefully, just the last half hour I've done some of that for you. Thermodynamics counts for everything. Electronics. 3 forces and the 4 forces of the universe. Gravity. Oh, I've got a good one for you. I think in 5 dimensions. X, Y, Z, gravity, and time. We don't think of that, but that's not just X, Y, Z. Oh, thank you so much. Thank you for listening to me. I went to Russia, and they had me talk like this for 3 days straight. They wouldn't let you in to talk to me unless you wore jeans and did not wear a tie and a coat. We wouldn't let any Russian talk to me who wore a tie and a coat. 3 days of talking like this. I had fun called fireside chats. I do lots of that at CoFest too. I don't get paid, but what the hell, it's a good vacation. What else you got for me? Keep the questions coming. My time is your time. No more questions? What's going to happen? Fusion power is going to happen. Fission power is going to happen. Lasers are going to get bigger and bigger. Computers are going to get smarter and smarter. And I like science fiction movies. Oh, that's me too. I do a lot of reading. I worked in stem cells. I worked in cancer for the Chinese army. I do all kinds of crazy stuff. Those stories they come. So if I'm in there and there, you come to COFED, we'll have some more time to talk for one of the other conferences. I just helped finish a book on the power of measurement, PAU. So it's a $79 cost book. But you might look some of my books up. I have some cheap, lousy books that are cheap and low cost as well. I mean, they get a book you buy, so I'm not getting rich on that for sure. But it pays for the copier. So anything else? I like that interest in learning. This is the beginning. I don't know. You look up the electron problem in physics. The one where the electron knows when you're measuring it. We're beginning to understand it. A little bit of the philosophical stuff. Almost everybody in the world has gotten a phone call knowing that phone call was bad before they picked up the phone. How can that be? But it happens to everybody. So the physicists are beginning to look at that too. How many the world changes? The world indeed does change. We're the few species that modify the environment to suit us. We don't change who we are to deal with the environment. We change the environment to deal with us. Doesn't mean you need a big brain and not big muscles. What else? Got more questions? Keep them coming, kids. No more questions? Well, you got my email. And if you put Morley on the top of the subject line, uppercase, all uppercase, put Morley on the subject line, I'll see it. I get 500 to 1,000 emails a day. So you want me to be serious about it, you got to put my name in uppercase in the subject line so that I know that it's you guys you're talking to. I try to answer them all, but as you know, it's tough to do. Well, ladies and gentlemen, whatever else I got to think about. Well, I do them about twice a year. Twice a year. I don't do courses. I do introduction sessions and Philadelphia philosophy stuff. I'm a one-day speaker or 1 hour speaker more than I am doing a course. I'm always, it seems to me, I do two or three days of something every month. Either academics, application specific, or philosophy. But nevertheless, don't wear a tie and a jacket. I didn't do that. The Russians did. No tie and a jacket. Can't talk to them all if you have a tie. What else you got? Well, I'm here anyway if you want to ask me another question or start another discussion. I've enjoyed talking to you, and I've had a good time. And we used up our hour. That's pretty good. We're right on time. I usually give the courses, the introductory courses, these courses, and the graduation discussion. You know, did you learn what you thought you learned? I do that for a magazine and Australian ABC. So they're both there. Well, you want to have fun, just type in Dick Space Morley and press search, and you'll find out all about me anyway. Just stick Morley and type in search, and have a good trip through the wonders of the internet. And I'll be signing off now unless you have some more questions or more discussion. I await at your pleasure, ladies and gentlemen. What else you got for me? Half time anyway. Half time anyway, right? Ladder Logic. Ladder Logic is one of the longest running software programs in the world. That's not my invention. It was invented by the Germans in the 1900s sometime back. But it's a go-to rather than come from language. It's the fundamental in the operating system of the PLC. Somebody left you on this fine. You can leave now. You gotta go pee and all that stuff. You can leave now. I understand that, but I mean, oh, which brand? I don't follow that. I mean, the three brands are, the one in the United States is, I can't think of the name of the company. In Germany is Siemens, and it's Scour in Japan. It's Snyder in the rest of China, the rest of the world. Yep. Siemens, Allen Bradley. That's Allen Bradley. And we get a couple of them. And they're all big ones. The business is a couple of $1 billion at the moment. We change the world, don't we? We don't play the guitar, but we don't get the recognition a guitar player does either. But they won't forget us, because when something breaks, it breaks because we did a bad job. Oh, good. Well, Snyder I'm affiliated with, but not for money. I just go to the conferences and stuff. Allen Bradley, I used to know the guys founder at Allen Bradley. And Siemens. To my mind, they're all kind of the same people. Siemens is Germany, Europe. Snyder is the rest of the world, China in particular. What's the United States? It used to be Allen Bradley. I mean, there's a lot of the one market that's burgeoning is mail office and on the chips. Yes, it's just an interface, that's true. The PLC is hands on an automation system. It's the hands that do the work. It's not the manager, which is the computer. It's not the owner, which is the dog that keeps the human from doing anything. You know about that. They always hire a dog to run every automation system. And the job of that dog is to keep the hands, keep the humans from touching the automation system. Pick one, pick one, pick one. Don't try to mix company sources. I used to when I was actually working. I have two major suppliers. I pick and an alternate job so I keep them honest. I would use Allen Bradley for one, Siemens for the other one. We automate between them so to keep them honest, keep the vendors honest, keep me honest. But I keep one source of vendors and the one in each system. Don't change, don't build a system with alternate vendors inside the system. Well, as I'm finding out that's all the universe is. The universe is just all in our imagination. And our brain is the interface between the one universe to the next. And that applies to PLCs, programmable controllers, microprocessors, laptops, which is my favorite. But I also use appliances. The iPads, iPods. Yeah, that's right. That's right. Can't help that. Can't help that. I always say, well, all I want in a programmable controller is have the working side, the single outputs, and the other side be internet compatible. That's my ideal programmable controller, internet compatible. That's machine-to-machine interface. And it's simple. It's gotta look like it's gotta be compatible with the internet and all the internet systems. And on the output's gotta be internet with all the digital stuff. And the in-between thing should be called a PLC. But so far it hasn't really happened. The trend is there, but so far it hasn't happened. I can't build a system with alternate suppliers of PLCs. What else we got here? Let's see. I'm reading my things. Simplicity. Keep it as simple as possible, but no simpler. That's right. You want to make the system more quickly and have it work forever, and you go home and sleep nights and not be worried about it. Don't let that icebox door open and let the light out, that's for sure. You know what a flashlight is? A flashlight is a dark eater. We want to have more dark eaters. Suction on that with dark to make light. What else we got? Keep them coming, guys. Keep them coming. One last one. Come on, come on. You guys are better than that. What's the next one? Gee whiz. Anyway, go to COFES if you can afford it. Go take 2-day courses at MIT or Caltech. Full days, 2-day course at Caltech. Take courses like this to get up on literally particular configurations you need to use. All computer learning is not very good. You need some hands-on learning. You've got to be able to deal with the instructor, for example, like we're doing now. Northern Iraq, huh? Well, you know something I'm amazed with? My brother worked in the State Department. He had to be careful how he traveled and where he went. I could go anywhere I wanted to. Why? Because I taught them how to get oil out of the ground. Yep. We called it the Pro PC in the beginning. We thought it was a programmable controller, which it was, of course. But Microsoft being who they are and IBM being who they are, we lost out. COFES, COFES, right? MIT. I'll look into it. Yep. And the West Coast Caltech is good. Harvard is also good, by the way. Sometimes you want to look at other things like business management and stuff. And it might be a good one to take an offline course rather than a technical course. Harvard, MIT, and Caltech are the three I recommend generally. Funny, I'm just thinking, I don't recommend any foreign courses. Well, for finance, I pick London. But that's about it. Oh, good show, good show. That means you're not rich. Give me some money. I gotta start just a startup for you. Oh, by the way, news for you. This is Dick Morley advice. A good, intelligent person can make interconnections that other people can't see. In other words, you can make connections that other people can't see. That's the key element, in my opinion, to IQ in the automation business. Got to make connections that other people don't see. Why, thank you. What else we got here? Oh, by the way, another one is, you know, on crime movies, they have tapes that say police line do not cross. Although they're real in the real world too. And the imagination is that the solution is inside that tape boundary. And it seldom is a complete solution. You have to step outside the tape, the police tape. Anyway, I'll see you on the next go around, guys, unless you have some more for me. Remember, make connections that other people can't see. Make things that last forever. Keep it simpler but no simpler. Cost of the product, not cost of the manipulation of the product, of the automation. And have a dog at the control system. Keep the people from messing it up. And good luck. Well, 10 minutes over. Pity. I think I'll take a nap. Yeah, well, come on and visit me. You get in the Boston area. You have to come up to the retirement home to see me, but in fact, I'm holding a conference in the dining room this coming week in the conference room. Yeah, we have a good time. Get a smile on your face. Every time you go to a lecture, you should come out of a lecture with a smile on your face. Not because you learned something. It's because you learned what you didn't know. Thank you for seeing me. Well, I'll be seeing you. I'm signing off now. Morley at barn.org is hitting the road. Good afternoon, ladies and gents, and have a happy. Do we have any female engineers out there? Nope, I guess not. Well, I'm going to sign off now. I'm going to go off. See you guys later. Have a happy. And thank you for listening to me.